Hello friends, welcome to a new algorithm of machine learning, that is decision tree classification and regression. Now decision tree is the first algorithm that we are going to see in classification category here, and first algorithm in non-linear regression category. This is non-linear regression, so decision tree is used for regression algorithm also. Let's see, many concepts are there that we'll try to understand from this particular presentation. Let's see an example. Suppose a job seeker was deciding between several offers and some closers or furthermore away from the home with various levels of pay and benefits. He or she might create a list with features of each position. Based on these features, rules can be created to eliminate some options. For instance, see, how can I choose this? If I commute longer than an hour, then I will be unhappy, or if I make less than $5,000 and I'm not able to support my family. So it's a difficult decision. Predicting the future happiness can be reduced to a series of small but increasingly specific choices. So we are having multiple choices with you. Based on that, you are going to decide the priorities of these choices, and we are going to identify which jobs to choose. So this is one of the example where you are going to have a tree based applications, and that's what the core concept behind the decision tree is. So decision tree is a graph to represent choices and their results in the form of a tree. The nodes in the graph represent an event or choice, and edges of the graph represent the decision rules or conditions. One of the most used machine learning algorithms and data mining applications also. Now, as you might intuit from the name decision tree, learners build a model in the form of a tree structure. The model itself comprises a series of logical decisions similar to a flowchart, which decision nodes that indicate decision to be made on the attribute. They split into branches that indicate the decision choices. The tree is terminated by the leaf node, which we call as terminal nodes, that denote the result of following combination of decisions. Okay. Now let's see an example. So the use of decision tree is like predicting the email is spam or not spam. So basically decision tree is a classification kind of algorithm. So we'll see classification first, how exactly it is used to predict whether the email is spam or not spam, whether the tumor is cancerous or not cancerous, or whether the loan is a credit risk or not. Okay, so generally the model is created with observed data. That's what we call a training data. Previous data should be available with us. Then a set of validation data used to verify and improve the model. Okay, for new set of predictor variable, we use this model to arrive at decisions of the category. So yes or no, spam or not spam, this kind of decisions will be generating out of this classification algorithm here. Now few more applications, credit scoring models can be used, or marketing studies of customer churn, or diagnosis of medical condition based on laboratory measurements. So these are the applications where we can make use of the decision tree algorithm. Basically decision tree is one of the most effective algorithm and the fastest algorithm coming under the classification category. Okay, it uses the heuristic approach. Heuristic approach is used by almost all ML algorithms, but here it uses the divide and conquer strategy. You might have heard about this name in algorithm design. So this approach is called a divide and conquer because every time it uses one feature value, and based on that we are going to split it. Next feature split, next feature split. In this way these operations are done. Beginning at the root node, which represent the entire data set, the algorithm chooses the feature that is the most predictive of the target class, and then go on using number of features multiple number of times. At the end we are going to have the final decision created there. Okay, so let's take an example. With an example we'll identify two examples. I'll be showing theoretically how to build a tree, and then we'll see one practical application of tree building system here using Python programming language. Imagine that you're working for a Hollywood film studio and your desk is piled with high number of screenplays. Okay, so I want to direct or produce a movie. So I'm a producer or director, and I want to decide which will be the next movie that I want to direct or produce. So number of screenplays are there with me. So rather than reading each one cover to cover, you decide to develop a decision tree algorithm to predict whether potential movie would fall into one of these three categories. Which category it will fall, whether that will become mainstream hit or critics choice or box office bust. So three categories are there. These categories we need to identify with the help of a tree. So remember, classification algorithm always works on the categories. So these categories we'll be using, and we'll identifying in which category a new movie will fall. Okay, so to gather for your data for your model, you turn to a studio archives to examine the previous 10 years of movie releases. So obviously, for building any kind of ML algorithm, we need a previous data, previous observation, previous experience. Okay, so we'll go to the film studio, we'll gather the data for 10 years movie releases. Okay, we are predicting 3 different classes, so we'll have 10 movies each from these 3 classes. After reviewing the data for 30 different movie scripts, pattern emerges. What pattern I am identifying here? So this seems to be relationship between film's proposed shooting budget and the number of A-list celebrities lined up for starring the roles and the category of success. It means that 2 factors are there, like budget of the movie and number of A-list celebrities lined up for starring the roles. These are the affecting factors. Means this will be your input variable, and output variable is the movie success. So which movie it will be, mainstream hit, box office bust, or critical success. Okay, so how to do this one now? Now we'll first of all plot this data on a 2-dimensional plane. So I'm having 2 features. It will be easy for us to visualize in that case. That's why I've taken 2 features here. So n number of features are possible. Now let's see. So I've done this scatter plot of this data over here. On this direction we have the estimated budget of the movie, and this direction we have the number of celebrities. They are incrementing like 1, 2, 3, 4, and here estimated budget will go on 10 crore, 20 crore, 30 crore, 40 crore, okay, above 100 crore, whatever. Okay, so 30 movies are present in the previous data, so I have plotted that. We just can see it. These green squares are containing the critical success movies are plotted there. Red circles, these are the box office burst movies plotted here, and the blue triangles are containing the mainstream hit. These movies are plotted over here. Okay, so plot is done. Now how tree building will be done? Now let's consider I want to split this particular data perfect horizontal or perfect vertical so that one class can be separated. Is it possible? One class can be separated. Now if you put any line, any perfect horizontal vertical line, it is not possible to create the classes in that. But if you consider that if some misclassification happens, then also we have to draw these lines. So then it is possible. How to? See, the first line is here. So if I plot this line here, so of complete all red classes, red points are coming below, and green and blue will go above. Till then 2 variables, 2 values are coming in the red class also. Means here we have the green square and blue rectangle. Okay, these 2 are coming under this class. But okay, it seems that every ML algorithm is not 100% correct. That's why this classification can be considered easily. Okay, now after this particular line we got 2 planes. One plane is above this one and one plane is here. Now again, is it possible to have one more line, horizontal or vertical, which will create 2 classes, or which will separate one classes from the original class there? Okay, you can see that it's possible here. If you draw the line here on this line, okay, check this, split number 2. So this blue are separated, this green are separated, and these red are separated. Perfect horizontal vertical. But still then we are having one misclassification here, one here and one here. So out of 30, 3 misclassifications present there. Now see, the splitting is done. Now how the tree building will be done? Let's consider if number of celebrities are less, then red is the class of it. When number of celebrities are high and budget is low, then green class is there. When number of celebrities are high and budget is also high, that case the blue rectangle, blue triangle class is present there. So 3 classes are present, and now this will be represented in the form of a graph, in the form of a tree, sorry. So that is what we call as the decision tree. How this tree will be built? Now let's look at this. First of all, 30 movies are present here. Out of 30, 10 are critical success, 10 are mainstream hit, and 10 are box office bust. So first criteria that I will apply here to split that data is number of celebrities. When number of celebrities are high, number of celebrities are low. Number of celebrities are low, 20 movies are present, 12 movies are present, and number of celebrities are high, 18 movies are present. So basically I have given high and low. Decision tree actually perform the operation with the help of the data. So above 5, below 5, something like that, it will have a split. Okay, when number of celebrities are low, 12 movies are there. Out of 12 movies, 1 movie is critical success, 1 movie is in mainstream hit, and 10 movies are in box office bust. So it means that now almost decision is approaching towards the box office bust. So when number of celebrities are low, then your movie can be the box office bust. Okay. Now if you go to the other side of it, that is when number of celebrities are high, 18 movies are there. Out of 18, 9 movies are critical success and 9 movies are mainstream hit. Okay, so 50-50 position is there. So it means that a perfect classification is not possible there, so that we are going to apply the second criteria there. Second criteria is the budget. Okay, so I am applying the budget. So budget is low. Out of 18, 8 movies are critical success. All movies are critical success. And when budget is high, total 10 movies are there. Out of 10 movies, 1 is critical success and 9 are mainstream hit. Okay, so budget, when budget is low, all movies are coming under critical success. It means that now decision is finalized, that is critical success. And when budget is high, that time 9 movies are in mainstream hit and 1 is misclassified. So mainstream hit is present over here. Now look at the leaf nodes. Here we have box office bust, first class, second class is mainstream hit, third class is a critical success. So we got 3 different classes over here after building the tree. Now how to predict? Next time when a screenplay will come, when budget is low and celebrities are high. So see, budget is low, so celebrities are high on this direction, budget is low on this direction, we will have the critical success. Now if I want the movie in box office bust, so I need to keep number of celebrities low, correct? And if I want the movie in mainstream hit, or if I want to predict the movie will go in mainstream hit, that time when the celebrities are high and budget is high, that time we will go to mainstream hit. How? Because my previous experience, previous observations are telling this. Okay, this is how the tree building is done. We are going to check one by one feature by this particular method, and once the features are identified, then we are going to build the tree in this particular way. So this is how decision tree model will be used for classification systems. Similar is used for regression system also, but the problem there is that we are having multiple different outputs from the regression model, and output nodes will be containing that regression outputs there. The algorithm that we use over here is called as C5.0 algorithm. So basically this algorithm is evolved 3 number of times. This algorithm was developed by computer scientist J. Ross Kinlan as improvement version of his prior algorithm C4.5, and which was the improvement version of iterative digitomizer 3 algorithm. And still this algorithm is available on this website rulequest.com. You can go there and check, it's present over that particular website. Okay, okay, before that we are having C4.5 algorithm, which was Java based open source alternative C4.5 titled J48, well available in RWeka package. Okay, so C4.5 is not now used. Now let's see the strength and weaknesses of this particular algorithm. Strength: it is all purpose classifier that does well on almost all the problems. This is my experience also. Decision tree algorithm gives the highest amount of accuracy in many cases, not highest, moderate accuracy almost in all kind of classification systems. Highly automated learning, can handle numeric and nominal feature as well as missing data also. It uses only the most important feature. That's also main property that it contains. The most important features, the features which are most important in generating the tree, only they are used over here in the decision tree model. It can be used with the data relatively few training examples also. If you are having only 10 sample, then also tree building is possible. Results in a model that can be interpreted without a mathematical background. Okay, direct mathematics are not present. It's present there, I'll show you in next slide. Then more complex, more efficient than other complex models. This is also one of the advantage. Now weaknesses. So they are often biased towards split. Features are having large number of levels. Large levels are there, so split will be more and it will become more complex. Easy to overfit or underfit the model. Overfit and overfit means perfect fitting, underfitting means it's not fitted well, not trained well. That's what underfitting means. Can have trouble modeling some relationship due to reliance on access parallel split. Perfect split should be there. That's why many times a perfect horizontal and vertical splits are not possible. That's why we will having trouble in modeling some relationships. Small changes in training data can result in large changes in decision logic. Yeah, that's also true. Large trees can be difficult to interpret than the decision that they make that they may seem counterintuitive. Okay, so these are the weaknesses that algorithms are containing. Try to remember that this is one of the most effective algorithm in many cases, and in terms of accuracy and speed, if you consider, optimized systems can be created so much easily with the help of this particular classification algorithm here. Let's see one more example. I'll directly show the tree for this example here. This is very classical example of decision tree algorithm here. You can find this example in many theoretical concepts when they are elaborated in for the decision tree. So this is a data set created by a golf player. He has played the golf on the ground or not. So 14 different situations are mentioned. So when outlook, temperature, humidity, windy were there, based on that the last variable, that is play golf, was decided. This is your decision variable. This is the class yes or no. Only two classes are present. So let's look at that. When outlook was overcast, temperature was cool, humidity was normal, windy was present, so he has played the golf like this. Or if you go here, rainy, when outlook was rainy, temperature was mild, then humidity was high, windy was false, so you have not played the golf. Now we are going to build a tree based on that. So the tree will tell you next time the golf player goes to the ground whether he has to play the golf on that particular ground or not. Is it possible to play there or not? That decision we can identify with the help of the tree created from this. Let's see the tree of this particular example. Total 14 samples are present here. Out of 14, 9 are play and 5 are don't play. So first I applied is outlook. Sunny is having 5, overcast is having 4, and rainy is having 5. Okay. In overcast, all are play. So overcast outlook is there, then all you are playing. But when sunny is there, 2 plus 3 is present. When rainy is there, again 3 plus 2 is present. So it is 60-40 situations are available. So here is applied humidity. When humidity is less, 2 play, and humidity is high, then 3 don't play are there. So that's it. A decision is finalized. And here also windy is chosen. True. When windy is there, 2 don't play, and windy false is 3 don't play. Decision is finalized. Total 14 situations are there. A perfect classification is done over here. Okay, you can look at it. A perfect classification is completed, and based on that the tree is created here. Okay, now you can see the example here. Temperature feature is not used. It means that temperature feature is not having any impact in the output. The feature temperature is not having any impact in the output. That's why this temperature feature is not used in building the tree. Fine. So it means that decision tree uses only the most important features. Only that most important features are used, and based on that the tree is created. So next time the golf player goes to the ground, he'll identify what is outlook, what is humidity, and what is windy. So based on that he will decide whether to play or not to play. So in this way the tree building is done based on the features input given to it. Okay, so that's how it performs. There are two concepts that you need to remember. On what basis the variables are deciding. So first is called as Gini index. Okay, Gini index means it's an error that particular feature is containing. So how to choose the split means which feature to choose for a split, decided by the lower Gini index. Okay, so Gini index will be chosen. The feature which is having the lowest error will be chosen for classification, and the feature which is having highest error, that will not be chosen. Similar to that, one more is there called as entropy. Entropy is called as information gain. It's a measure of uncertainty of a random variable. It characterizes the impurity of arbitrary collection of examples. It is higher the entropy, the more information content. Okay, so information is present, more information present, that will be chosen to perform the split. That's called as entropy or information gain concepts. Okay, so this is what the theoretical concept that you need to remember for the decision tree. Now we are going to perform the operations of building the tree of decision tree classification system. So what packages we require? We require pandas, we require sklearn, we require, okay, for visualization we require IPython, we require graphies, we require py.plus. So IPython, graphies and py.plus, these are three packages which are coming under the Python repository. You can download from Anaconda system also, IPython, graphies and py.plus. If you are using Linux, we'll be using this method to install it. And one more is called as graphies. This package also required to install in your operating system. So this command I am showing over here, it is Linux command, but if you are using Windows, okay, if you are using Windows, so that time we need to download this, see, graphies graphical visualization software. This is graphics.gitlab.io. From there you have to download this particular software. See, it's present over here, graphics 3.38.msi. It's required only for tree visualization. If you don't want to visualize the tree, this is not expected. Okay, so check it whether it is compatible to your Windows version or not. If it is compatible, it will show the tree. Okay, so this is required. IPython graphics 5. These are required for the tree visualization only. If you don't want to visualize the tree, then these are not required. Okay, so let's go for the practical application. Okay, decision tree classification. Now we'll predict whether the banknote is authentic or fake depending upon the 4 different attributes that image of the note is. See, so let's see the data set first. So data set that I'm using over here is banknotes.csv. You can download this data set from the given link mitu.co.in/dataset. From there the data set can be easily downloaded. Okay, so let's see what it's containing. See this one. The data set is like this. Okay, so what the data set is containing, you might have seen the fake note identification machine. So what they have done, there are 4 image properties of the but that note are present: variance, skewness, kurtosis, entropy. So we have identified the fake note. These are the fake notes. Class 0 is present. The class is identified whether the note is fake or not fake. Okay, you can check it. I'll go below class 1 is present. These are the original notes and their properties are present. These are original notes and above are the fake notes. Okay, so this data set is created by accessing the properties of fake notes and original authentic notes separately, and then data is created. So these are the fake notes. You just can check, is there any similarity these fake notes are containing? No, not actually. No similarities are there. And if you go for original note, again there is no any similarity present there. Now how to identify that whether a new note is coming inside the machine is fake or not fake? So what we will do, we'll build a tree based on these 4 features. We'll build the tree based on these 4 features. Now once the tree building is completed, then we are going to predict a new note is coming under which category. So we don't know which feature, variance, skewness, kurtosis, entropy, is used to classify the note perfectly, but your decision tree algorithm will do this task for us. Now how it will do it, that we'll check. Okay, so remember the data set. What's meaning is, I'll download this data set from this link, archive.ic.uci.edu/ml, the data sets bank note authentication. So this is available on the MITU Skillologies website also. You can download from that position also. Okay, so remember that the data set is this. It are the image properties of the notes, and based on that we are going to classify, we are going to identify whether the entered note is coming under which category, fake note or the authentic note. Okay, so let's go to write the program here. Okay, so let's have written the program, and let's continue with using this particular program. Okay, so let's read it. First thing, I imported the packages required for me. Here I am reading the CSV file. Data is equal to pd.read_csv banknotes.csv. Now shape I have seen. Total 1372 rows are there and 5 columns are present. What are the 5 columns? Variance, skewness, kurtosis, entropy and class. Okay, so these are the 5 columns present there. Then I'm going to check, is there any missing values present there or not? Data.isNull.sum. Okay, so check it out. All 5 columns, no missing values are present. Now what we require, what are the input variables? These are the 4 input variables that we have and 1 output variable. So in X I'm going to put the remaining 4. So I'm dropping class and remaining 4 I'm putting inside the variable X. Either this method, so we have seen this method, X is equal to drop class, X is 1 means class is a column name, not a row name. Or I can use this exactly column number 4, that can also be chosen. I have put it in comment, or this method can also be chosen. But this is complex because we need to write the all column names here to get it. That's why I am using the first method, dropping, and output variable I am keeping into variable y. So X contains 4. You can check this. X.head, variance, skewness, kurtosis, entropy, which is 2-dimensional data frame created there, which contains the 4 input features of our data set, and output is y. Okay, so output is y. Now how many classes that y is containing? There are two ways by which we can find how many classes are present. By using numpy's unique function np.unique y, you can see array 0 1 means how many possibilities of outputs are there in y that we can find with the help of unique function. So array 0 1, or you can convert the data into set format. We have seen this set already. This is one of the prime application of set in the machine learning algorithm of classification system. Okay, it's showing two unique values are present there, 0 and 1. Okay, and if you are printing this array format, you can see that 0 1 0 0 0 1 are present. Remember that data is sorted according to the class. Previous all entries are 0 and remaining entries are belonging to one category there. Okay, now let's build our classifier. So before that, we need to separate your train and test data. We identified why to separate that, because training data will be used to train the model, will build the model, and on testing data we are going to check whether the algorithm is generating the correct result or not. So original data and predicted data, that we are going to compare, and we'll identify how accurately the decision tree algorithm is performing the classification system here. So let's import sklearn.model selection, import train test split, and here after that, after this imported, I am going to split my data in two different format. See how it is: xtrain, ytrain, sorry, xtrain, xtest, ytrain, ytest is equal to train test split. Okay, here I have given x input, y output, random state I am keeping 0, and here I have not given the test size. Test size is by default 25%. One more parameter that I can specify, like test underscore size is equal to 0.25. But remember, by default test size is always 25%. That's why I'll skip this for all algorithms onwards. Now after splitting is done, total 1372 entries are there. Out of 1372, 1029 entries are coming under training category. Remember, it is randomized. They are not in sequential order, because you can see the data is sorted according to class. So if you want to build a perfect classifier, all the data, training data and testing data, should be randomized, and after that it will be used inside the algorithms. Okay, so xtrain 1029 entries, that is 75% entries are going here, and 343 entry, that is 25% entry, will go here. And if you see the head means you can just check it. First 5 entries in training data, check this. First entry 662A, 512, then 1193, then 682, then 1313. Okay, all they are randomized. Same case is there for y train also. Y train will also contain the similar order, and x test and y test will come in similar order, but their entries will be different. So randomized data from data set is given to the training data 75%, and 25% is given to testing data. Okay, fine. After that, we are going to build the classifier. So from sklearn's tree subpackage, I am having the class called as decision tree classifier. So this class is used to build the decision tree model. So let's import that, and after importing is done, we are going to build the classifier here. So classifier is the object of decision tree classifier. Random state is equal to 0. Okay, so random state 0, it means that randomization inside decision tree will be starting from the seed point 0. Okay, random state 0, classifier is created. So let's build this, and after that we are going to train the algorithm with given data. So trained classifier object dot fit, it is used to train the data with x input, y output. So total 1029 entries are given here to train the data and to build the model of the decision tree. Okay, so here decision tree is created. Okay, created with the given data, and now what we are going to do, let's see this. I'll just revise our concepts. Okay, so this splitting that we have done, for example, this is your x train, this is y train, x test, y test. So we build a model on this data only, input output, and now what we are going to do, we are going to apply this as the input, and we are going to identify whether this output we are generating or not. Okay, how many entries of this 343 test data is equal to data predicted by the algorithms. Okay, so this comparison will show you how perfectly the decision tree classifier is behaving. So let's go for that. So this building is done. Now predict. Okay, what I have done here, See, classifier dot predict. So X test data I have given, 343 entries are given here. It has predicted all the entries and their classes are generated here called as ypred. Okay, so ypred I got here. Now ypred and ytest, two things are there that we need to remember here. I'll just show you the things which it contains here. So let's add one more cell. Okay, so this is ytest. See, ytest is a combination of all the 01, 01 their respective classes of test data set. And if you go to pred, see, they are the predicted classes by the algorithm. So we are going to compare ytest original data set plus ypred, which is predicted by the algorithm. Okay, so that's what we require here in this case. So to do this one, we are going to have a concept called as confusion matrix. So how to compare x and y together? If you see these entries, they are almost same. Or if I create a result like see pd dot data frame, I'll create. Okay, in this let's have a dictionary created here, and inside it actual values. I'll put actual values as y test, comma, predicted values as y pred. Okay, finish it. Now see, this is actual value of the data and predicted, and you can see actual in ytest is 1 and predicted by algorithm is also 1. Here 0 0 1 1, and if you see almost they are matching. Is that the case? Actually they are matching. Okay, some entries are truncated here. Okay, that's why they are not visible here. First few and last few are only shown. Okay, that's it. That's how it's present there. Now I want to identify how many entries are matching and how many are not. To do this one, we are having a concept called as the confusion matrix. With the help of this confusion matrix, we are going to compare how many entries are matching in test data from test data into predicted data and how many are not matching. So how to do this one? So let's see. Confusion matrix is the error matrix, is a specific table layout that allows visualization of performance of an algorithm, typically the supervised learning classification system. Each row of the matrix represents the instances of predicted class, while each column presents the instance of the actual class, or vice versa. So actually it's inverse in the Python case. Okay, so let's see how it is actually performing the operations. Let's see this example. If a classification system has been trained to distinguish between cat, dog and rabbits, a confusion matrix will summarize the result of testing algorithm for further inspection. Assuming a sample of 27 exam animals, just take an example. I want to predict whether the animal is dog, cat or rabbit. So total 27 entries are there in the test data set. Out of 27, 8 are cats and 6 are dogs, 13 are rabbits. And I am predicting the data, okay, on this 27 by any machine learning algorithms. So it shows the confusion matrix in this way. See this. This is predicted class and this is actual class. Predicted class, like for example in actual data set, total 8 cats are there. 8 cats. Check. Out of 8 cat, 5 cat are predicted as cat, but 3 cat are predicted as dog by the algorithm and 0 cat as rabbit. Okay, out of 8. Now out of 6 dogs are there. 2 dogs are predicted by algorithm as cat, 3 dogs are dog and 1 dog as rabbit. Okay, and out of 13 rabbits, 0 rabbit predicted as cat, 2 rabbit predicted as dog and 11 rabbit predicted as rabbit. Now let's look at that. In 27, out of 27, 5 plus 3 plus 11, 19 entries are matching. Okay, out of 8 cat, 5 cats are matching. Out of 6 dog, 3 dogs are matching, and out of 13 rabbit, 11 rabbits are matching. That's it. That's how the confusion matrix will show you in n by n format. N means number of classes. Okay, and if you see in actual binary classification, cat and non-cat, so when cat and cat is matching, this is called a true positive values. Against that we have true negative values. They are positive for other class like non-cat. These values are called as false positive and these values are called as the false negative. So out of it we are going to focus on true positive value at maximum number of times. Okay, now true positive are the actual matching in the data set. If you understood this particular concept of confusion matrix, then we will go to identify this in our case. So we are having only 2 classes now. So first of all, I am importing the confusion matrix function from the sklearn.metrics sub package. So let's import that and now print the confusion matrix. What's the meaning of this? Let's formulate it. So total 343 entries I am having over here. Total 343 entries are present. Out of 343 entries, we just can see confusion matrix is printed here. From this direction, above direction, we are having the predicted class. Okay, so you can see this one here. Here actual class is given, for here we have predicted class, and from this actual class, it means that out of 343, 191 plus 4, 195 entries belong to 0 class, fake note, and 148 belongs to the authentic node, that is class number 1. Okay, and this is predicted class. Okay, so out of 195, 191 zeros are matching. Okay, and 4 are predicted as 40 are predicted as 1. Okay, so expected 0, predicted is 1. Similar to that, from this direction, this is a 1 class. So 1 predicted as 0 3 number of times, and 1 predicted 145 number of times. So total 191 plus 145, that is 336 entries are there which are matching out of 343. So if you write 336 divided by 343 into 100, we got 97.95% accuracy. Getting this? So this is how the confusion matrix, the error matrix, which will represent the summarization of class matching and not matching in case of classification algorithms. Okay, so just remember that how it is actually performing the operations. Okay, confusion matrix. So from this side we have above side we are having predicted, from this side actual. So actual 191 are matching with predicted 191 here in 0 class, and actual 145 with predicted 145 are matching, and these 7 are the misclassification. These 4 which are actually 0 predicted 1, the 3 are actually 1 predicted 0. Okay, so 7 are mismatching in our case. That is what the error rate we are having. Almost 98% accuracy we can achieve from there. Now if you want to see this accuracy by the function, so in matrix package itself we are having accuracy score. Let's run this and print the accuracy score. Accuracy score, we have to compare y test against y pred. Y test is the original data, y pred is the predicted data into 100. So same output is generated there. You can check it, 97.95 with the formula how we identified how many are matching, how many are not matching. Based on that, accuracy score is identified and it is printed on the screen there. Okay, getting this. So there is one more system called as classification report. Let's see this. From sklearn.metrics, I am importing the function called as classification report. So this classification report function I have imported from the sklearn.metrics. Okay, and then it's printed something like this. You can check it out. Now what's the meaning of this? Let's understand. There are 4 properties. There are 4 properties that it contains. First is support. See, in the original data, out of 343, 0 class were 195 and 1 class of 148 present. Okay, means fake notes were 195, 1 note were authentic note were 148. Okay, total is present here. Now out of it, out of 195, how many entries are matched? That is 98% entries are, sorry, here 98% entries are matching. Okay, means 4 are mismatching there. That is 98% accuracy you are getting. And out of 148, you can see this one, out of 148, 145 entries are matching. It means again 98% recall is present. Recall is called as individual class accuracy. For individual separate class, how many entries are matching is called as the accuracy score of or recall of the respective class. Okay, so recall is 98% in both the cases. Out of 195, 191 are matching, and out of 148, 145 are matching. So both case we have 98% recall. Now if you consider precision, precision is called as true positive rate. True positive rate. So in the predicted class, how many entries are true positive? Predicted class, how many entries are true positive? How it is identified? See, in this direction, predicted class is this 194, 191 plus these 3. Predicted class is from this direction. Out of 194, 191 are matching, that is 98% for first class, and out of 149, 145 plus this 4 predicted class. Okay, so 97% is the precision of it. True positive rate, how many entries are true positive in the predicted class are this 98% for first class, 191 out of 194, and here 97% means 145 out of 149. Okay, this is called as a precision. Getting this? So precision which is called as a true positive rate. All this can be identified with the help of a confusion matrix also. Okay, so they can accurately identify whether your algorithm, classification algorithm, is behaving correctly for all the classes or not. And you have to make sure that all these precision, recall and F1 score should be above 0.80%. Then only classification system is working correctly, that we can identify. Let's come with the third point, F1 score. F1 score is called as the harmonic mean of precision and recall. It is direct mean. You can see 98 plus 98 divided by 2 is 98, or 97 plus 98 divided by 2 is 98 somewhat. Harmonic mean of F1 score. So this should also be present above 0.80, means 80% above harmonic mean or F1 score should be present, and that will decide perfect utilization of this particular algorithm there. Okay, so classification report is one of the most important function to identify the usefulness of particular classifier for the given data set. That's why you just can try it and check the output. Fine. So this is how we can identify it. Before actually predicting the data, performing the single entry prediction, I am going to do the operation of showing you the tree. So how to view the tree? In order to view the tree, so a simple method I am using here. Actually many steps are there inside it. From sklearn.external.6 I am importing a string IO class whose object you have to create first. Then from ipython.display I am importing image class whose image generation is possible by using this. Then sklearn.tree I am using export graph views. So we have to create the graph from tree. So that's possible with the help of export graph views. Okay, that we can make use of. And then the last one, import the pi.plus. Pi.plus is used to write the data directly from the graph. Okay, so that's 4 are imported. Let's import them. Okay, now let's go for the next. Create the object of string IO dot data, and now export these. This function is containing first parameter is a classifier object, decision tree object to build the tree. Second parameter is the out file name. We create a string IO object first, then parameters which are not required, field equal to true. I want a colorful tree. To do this one I am making true. Rounded rectangle will be there in the nodes, that is I am making true, and some special character like superscript or subscript which are required in the tree, they are also given true. If it is not given, that superscript and subscript parameter will not be shown. Okay, so let's okay, it's executed. Now let's go for the next. Pi.plus.graph from .data. The object that we have created, from that we have to create the graph. So this parameter is given here, and from this parameter I am going to get the value and store in the graph, and from graph we are going to use write.png function. So once it is executed, the tree will be formed. See this. This is how the tree is created. So it's showing true actually, but the tree is saved in the current working directory by the name tree.png. So I'll show you the tree which is generated here. Let's go for the home directory. See this. So this file called a tree.png is created here, and that will show you the perfect tree. Okay, sorry, its working directory is different. Working directory is there in ml dt. Yes, it's a tree created here. See this. So in current working directory, the tree will be formed, and you can see this. Check it out. This is a tree generated, and will do the classification for us. Now see how it is created actually. So first of all, x0 feature is used. X0 is variance feature. X0 here, x2, see x0, x0, x1, x0, x2. So these features are used. Number of features. If value of that is less than this, then true on this side and false on this side. Guinea index, that is the error impurity, here is 0.495. Number of samples that we are having in training data is 1029. Out of 1029, these are the 0 class entries and these are 1 class entries. 0 class entries and 1 class entries. And now this condition satisfied will go here, and this condition not satisfied will go here. Out of again 1029, here 495 entries are becoming true and 534 entries are getting it false. Okay, they are giving here. So second criteria I am applying there with error rate as 0.298, samples are 495, 0 are 90 and 1 are 405. This case I am using second feature. Okay, second feature value is less than minus 439.4394. Again index is 0.191, samples are 534. Okay, total samples are 534 here, and out of 534, 0 are 477 and 1 is 57, like this. So in this way the splitting will be done, and if you go here you can check this one here on this direction. 8 and 24 are there. Out of that, all 24 are coming here. Guinea is becoming 0, sample are 24, class 0 are 0 and class 1 is 24. So every leaf node contains it. See, every leaf node is containing this 4 0 0 1 0 6 2 0 0 21. Okay, check this 6 0 12 0 0 4. A perfect tree building is done. Total 9 levels are there in this particular tree here, and based on this tree we have done the prediction of the data. So when new node comes, it will go through this x0 x1 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 x2 x3 like all, and when based on that the final leaf node will show you. Now see the color notations. The orange is class number 0 and blue is class number 1. So the shades of this is actually showing this particular node is having the domination of which particular class. Okay, that will be shown. At the root node, domination is not there, almost we are having 50-50. That's why the color is almost very faint orange, and see the tree perfectly created there. Okay, so you just can check it on Windows, it's working or not correctly, because some versions of Windows are having problem of installing the graph piece correctly. Okay, now this is how the tree building is done. Now let's go for single entry prediction. So what I want to do, I will use variance, skewness, kurtosis, entropy again, and then I will predict what is the class of this particular node. So let's have a node. So let's enter the node. First node is its property is something like this, 0 minus 0.6464. Now second is 4 point something skewness, then kurtosis. So I am reading this data from the user, 1 point some data, and then the last entropy is minus 0 point something. Yes, so all 4 values are available to us. Now how to predict it? So let's see. I'm using new is equal to np.array variance, skewness, kurtosis, entropy. So they are converted in array format. We can convert in data frame format also, or we can convert into the list of list format also. Anything is possible there. So convert it into that particular format, and after this we are going to create the variable of that type. It's created, and now let's the final step. I want to find whether this node is predicted as accepted or rejected. So how to do this one? I'm going to make use of classifier.predict function, new. This parameter I am passing here. So this node which I have entered from the user is now fake or not fake, coming under 0 category or 1 category that we can find. So pred, I got this. So it's 0 value, because result is always in array format and containing only single element. That's why 0th element I am taking is equal to 1. 1 means node accepted, and if it is returning 0 by this prediction, then node is rejected. So let's see, node accepted. Yes. For the data entry which I have done from there, it is matched with, it is traversed towards the tree, and at end it identified that the node is coming under authentic category, that is not fake category. That's why it is showing node accepted. So this is how we are going to do the prediction based on the data input given there. And the most important thing is how to characterize the classifier systems. So classifier systems also we have characterized here by confusion matrix, by classification report, by accuracy score, how your train test split is done, and how we have done the prediction, single entry prediction. So to automate the system of finding the node is fake or not, we can use this particular program to identify whether the node is fake or not fake. So this is how decision tree classification system behaves. Decision tree classification system behaves. Now let's go for, you can try this example, will be given along with this video also. Now see the second part of this particular presentation is called a decision tree regression. So let's go for that regression. So it's what we have done, regression. The process of solving regression problem with decision tree scikit-learn very similar to that classification, but the class name that we are having here is decision tree regressor. Also evaluation matrix for regressor differ from those of classification, and rest of the process is almost same. So let's use the data set. The data set name is petrol consumption. So let's go for that. We'll use the data set by predict the gas consumption in million of gallons of 48 United States based on the gas tax in cents, per capita income in dollars, paved highways in miles, and the proportion of population with driver's license. So I downloaded data set from the given link. It's available on MITU's website also. You can download from there. Let's explore the data set first. Petrol consumption. So let's go for that. Petrol consumption. This is petrol consumption data set. Okay, so let's open this. Okay, now why I'm talking about the regression problem here? Because see, these are the input variables to me. Okay, so this data set is created from 48 different states of United States of America, where the petrol consumption is the output variable, and based on these 4 inputs we have to identify what will be the petrol consumption of the particular driver if the values are like this. When petrol tax is this, average income is this, paved highways are this, and population driver license is this. Okay, and then we'll check the prediction of this particular data. 48 entries are present. Regression problem because you can see there are no classes present here. It is containing only continuous valued output here. Okay, that's why we are going to make use of the regression problem here. Okay, so let's continue writing the program. So much easy. Yes, regressor. So let's import the pandas, then import it, read the petrol consum.csv. See the shape, 48 rows and 5 columns are present. Out of it, first 4 columns I have to keep in x, that is by dropping petrol consumption x is equal to 1 and output variable petrol consumption is in y. So let's add one row here. Okay, and check x dot head. Okay, see this. Okay, so these are the input variables to me. For this case, I have just separated them in x. See the head of join, first 5 entries are shown here clearly, and y will contain the petrol consumption. This is I have separated. So input and output variable I have separated here. And now let's split the data in train test split format. Sklearn model selection, import train test split, and then split the data. X train, x test, y train, y test is equal to train test split x, y, and random set 0 by the test size is by default 25% in this case. So 25% entries will go to train, sorry, test, and 75% entry will go to the test. Okay, so that's splitting that we are going to do there. So splitting is done. Now we need to import. Okay, let's check one more thing here. How many entries are going inside the training data? So let's check this. So length of x train, okay, is 36. So 12 entries are there in test and 36 entries are there in the training data. So let's import the class now. From sklearn.tree import decision tree classifier. So decision tree classifier class I am importing now from the tree sub package. Now create the object of it. Regressor is equal to decision tree regressor, random state equal to 0. Okay, random state is 0. Regressor dot fit x train, y train. So we are training our algorithm with this data. 36 entries are present there. So it's trained. And now for remaining 12 entries I am giving this input to the algorithm, regressor algorithm dot predict. So again 12 predictions will be there. So y pred is predicted by the algorithm and y test is originally that we are having in the data set. Okay, so that's it what we have done, and now let's compare them together in this format. Yes, result is equal to pd dot data frame. So first column I will have actual value which are y test, and second column in data frame I will have the y pred which are the predicted values by the algorithm present there. Getting this? And now print the result. Now see this. Actual 534, predicted 541. Actual 410, predicted by algorithm is 498. 577, 628. 571, 628. 577, 628. 4704, 644. See this. For 12 entries, you are predicted by the algorithm. Exact matching is nowhere. Nowhere exact matching is present. Why? Because this is a regression problem, so it will find the data close to the output. As the regression problem is present, exact outputs are not possible. So this is how classic regression system behaves. So in non-linear regression, we are not going to use any score function, just like linear regression, to find the accuracy of it. To find the accuracy of the algorithm, we are going to make use of mean absolute error function or mean squared error function. So let's check this. If you see this one, it will show the error. It's not correct, minus 60 something. Okay, so we are having two functions called as mean squared error and mean absolute error. So let's see how it is identified. So mean absolute error is 68. How it is identified? The average difference between these two. Okay, average difference between these two is called as mean absolute error. Yes, mean absolute error. We have seen that in linear regression already. And if you go for the mean squared error, okay, so find the mean, add them, sorry, square and then add them. So that's what we are having, 5731325. Okay, and root mean squared error is square root of the mean squared error, is called as RMSE. It's calculated here. Security of mean squared error, y test and y pred. So y test, original data and y pred, only these values are given as input to them. Okay, and now if you want to find the error in the output finally, so this is how it is calculated. See, average of actual minus forecast divided by actual into 100. See, so that will be containing the error, and we are decreasing this error, we are removing this error from 100%. So 100 minus np dot mean of y test minus y pred divided by y test. Okay, so the average difference in all we are comparing with y test, okay, into 100, that will be the error generated by this. This error I am subtracting from 100, so I will get 87. Say this np, sorry, np here I need to import. See, so 87.05% accuracy of this algorithm is present there. You can check this, how it is calculated. Test data minus predicted data divided by test data into 100, that is the error. Okay, and 100 minus that value is called as accuracy of it. So 87% time the entries are matching, it's almost they are close. Predicted output is close to the actual output 87% times. Okay, that's how the operations are possible. This is how we are going to characterize the regressor systems, the regression algorithm system. In all the non-linear regression coming afterwards, every non-linear regressions accuracy can be found with the help of the similar method. Okay, and now let's do a single entry prediction. So the single entry prediction means this. Okay, how it is calculated? So let's go for that. Petrol tax I kept. Okay, so petrol tax is 7. Then we are having average income is 9865. Then paved highways are 1586, and finally driver professional license is 0.58. Okay, and now do the prediction. Regressor dot predict new. So what will be the petrol consumption for this particular data, which is 524. Okay, so if I change this, if I change petrol tax to 5.8, okay, the second parameter is 8865, third parameter is 1956, and third parameter is 0.51. So let's predict it. 414 will be the petrol consumption for this particular state. Okay, so this is how single entry predictions are possible for the given data with the help of decision tree regressor, and even the same code of building the tree, visualizing the tree can be used here to show how the tree, decision tree regressor's tree will look like. Okay, so this is how decision tree classification system and decision tree regressor system behaves to perform the operations. The programs and data sets are given to you. You just try it and practice the same again on different data sets also. Thank you. Thanks a lot.